Hello everyone. So in this video, we'll be looking at the question add two numbers. And even though it says that it's a medium level lead code question, honestly, don't fret, don't worry, because the question and its solution is as simple as the name suggests. We only have to add two numbers and return the answer. That being said, it is not as straightforward as one might think, of course, because there are linked lists involved. So we'll get into the problem statement, we'll try to understand what it is about, we'll break it down, then we'll discuss the approach, we'll discuss how we can solve this question theoretically. Now, let's start with the problem statement. We are told that we've been given two non-empty linked lists. What does that mean? First finish the sentence and then we'll get to it. Two non-empty linked lists representing two non-negative integers. So non-empty linked lists imply that we will always be given two linked lists that have some value at any given point in time. So if we have to add 2 plus one another number that gives us a sum, this can't be a null value or a non-existent value. This has to be some value at any given point. That is what is meant by non-empty. It will at least have one node and that one node will have a value. That's basically what it means. Representing two non-negative integers. That is just to clarify that we are only adding two numbers and there will be no case where we might have to subtract. So that is just a clarification that they've given us, which is very good because we don't have to assume them. Now, they say that the digits are stored in reverse order and each of the nodes contains a single digit. Add the two numbers and return the sum as a linked list. This part seems pretty straightforward, but the sentence over here, what does this mean? The digits are stored in reverse order. That means that, taking this example as reference, this simply means that we are adding the numbers 342 and 465, and we'll be given an answer that is 807. Okay, that is basically what they're telling us, that this is what you're adding, but we will provide the linked list to you in reverse order. Now you may think that this is a little more confusing. Why is this in reverse order? Why is this not in the actual order 342? Why are they reversing it? Just wait for it. Trust me, the fact that it is in a reverse order makes things simpler, and we'll see why. Okay, that's basically the question. Let's talk about how we can start solving it. So we can start by taking a simple example, and for this I'll need to throw you back to your elementary school, your grade school, your class 1, class 2, or depending on wherever you're from, whenever you started learning mathematics. One of the first things you learn is numbers. The next thing you learn is adding numbers, right? So that's basically what we have to revise here. Sounds very childish, very beginner friendly, but it's important because we're going to use this exact logic in our code. So how do we add two numbers? We simply add them. 3 plus 6 gives us 9. 2 plus 5 gives us 7. 1 plus 4 gives us 5. And the answer that we have to return in such a case is a linked list. The linked list will look something like 9, 7, and 5. That is all that we have to do. But there are a few cases that we have to handle. For example, what if I decided that this right here, or let's erase these two digits. Instead of this, I will put 7 and 8. What will my answer be in that case? And how is the answer calculated in that case? So 3 plus 6 stays 9, but 8 plus 5 now is not a single digit answer, it is a double digit answer, right? What do we do in case of double digit answers? We write the sum part, we remove the carry, we add the carry in the next operation. So we get 1 plus 7, 8, 8 plus 4 is 12, 12, 39, and we'll return answer in a similar fashion, that is 9, 3, 2, 1. That will be the linked list that we return. So basically, the first example was simple addition, the second example was simple addition with carry involved. Then another example that I'd like to point out is when, let's say, we have another digit involved. Let's say 9. How do we solve this? 3 plus 6 gives us 9. 8 plus 5 gives us 13. 1 plus 7, 8 plus 4, 12. 12 and 1 plus 9. Plus, we have to assume that there's a 0 here, right? That is what we do when we try to actually add two numbers. We assume that it's a 0 in this place. So we have ones, tens, hundreds, and thousands place. We assume that there's a 0 in thousands place. So 1 plus 9 is 10 plus 0 is again 10. So 1 and 0. So we return 9, 3, 2, 0, 1. That will be our linked list. So these are basically a few of the cases that we have to handle. And how do we go about it? It's also quite simple. So let's erase everything. Let's take our example once again, or any random example, 9483 plus, let's say, 729. How do we get it in the form of a linked list? In the form of a linked list, we get it as in, and make sure that you remember this point, that the linked list is given to us in a reversed order, right? So we have 3, and in the second list we have 9, then we have 8, 4, followed by 9 as the last digit, then we have 2 and 7, and for the sake of clarity, I'll add another digit over here, something like this. Okay, so this is our linked list, right? I have listed it down in reverse order. I mentioned earlier that that is actually making things easier for us. Now, why is that? That is because when we actually add the questions, we sum up ones place followed by tens place, hundreds place, thousands place, followed by 10,000 place. What they've done is they've simply given the input to us in that very order, so that we can easily solve ones place, tens place, hundreds place, thousands place, and so on. So that makes things easier for us. Now, how do we actually go about solving this particular question? So I say that there are roughly 4 cases that we have to handle over here. First case, but before we get to the cases, we have to follow a simple iterative approach. Iterative approach, which means that we'll be processing one set of numbers at a point. There is one, then there is another one, then the next one, and then so on and so forth. All right, that is what we have to do. We'll iterate over each set of numbers. We'll sum them up. We'll go on to the next one. That is what we have to do. Okay. So how do we go about it? Case 1. Since we're following an iterative approach, for every iteration, for every combination of numbers that we encounter, there are 4 cases. Case 1 is when both numbers are present, right? Both numbers are present. That means we have the first number and we have the second number. So let's just worry about this case and try to start solving this question. So 3 plus 9, it gives us 12. As mentioned earlier, we keep the sum 12. That is nothing but sum is 12, right? 2 would be sum modulus 10. If you're a computer science student, I'm sure you know what this operator means. And then the carry. So let's call it the value, and the carry is sum divided by 10. So that is, in this case, it is 2. In this case, the carry is 12 divided by 10, that is 1. We bring the carry over here. Okay. So we keep checking whether this case satisfies or not. Okay. So do both numbers exist? Are both numbers present? The answer is yes. So what do we do? Number 1 plus number 2 plus the carry. So number 1 plus number 2 plus the carry. Okay. 8 plus 2 is 10. 10 plus 1, the carry, is 11. We'll follow the same logic. Value will become 1. Carry will become 1. We move on. Are both numbers present? The answer is again yes. So number 1 plus number 2 plus carry gives us 12. Value is 2, carry is 1. Okay. That brings us to the next case. The next case is only one number is present, which is 9. The other number is not present, in which case we'll just assume this to be 0 as we specified earlier according to the rules of addition. Then 1 plus 9, basically 9 plus 0 plus carry becomes 10. So the value is 0 and the carry is 1. So basically we mean n1, which is number 1, the only number that is present, plus 0 by default, or we can just skip writing this because it is basically the same thing, plus the carry. That is what we calculate over here. Okay. Then case 3. Now we would say, what is case 3? Well, it is basically an extension of case 2. I said that only one number is present, but we made an assumption that the first list is what will have the extra number and second list will not have the additional number. In reality, we can get an input where this smaller number could be the first set of input, the second input could be the longer one. So this basically means only one number is present in list 1, that's in L1 in case you can't read. Only one number present in list 2, and in that case we do n1 n2 plus 0 plus carry. That simply means that if the roles were reversed, if we had to calculate, basically whenever we are calculating, we're taking n1 and n2 as the two entities, right? n1 being the number in this list, n2 being the current number in the other list. So in this case, we'll only be taking care of n2 plus 0 plus the carry. That would make no change in this example, but it would when we actually solve the question. It will help us pass more set of cases. Now coming back to our problem, I want to change this number to 9 for clarity's sake, so that I can introduce another case. So 1 plus 9 gives us 10. Value is 1. The carry is 1, which brings us to case number 4. Case 4 is no numbers left. So in that case, we just add the carry. We add the carry and return our answer. And the linked list will be returned in this very order. So that is basically how you solve this particular question. These are the cases you take care of. And that's basically what you have to do. You have to keep processing till you run out of both numbers in a combination. Then you keep processing till only one number is left in either of the lists. Then you keep processing till you have added the carry to the rest of the result. And then you simply return your linked list. And that's how you approach this particular problem.